Welcome to the DNA Podcast. In this episode, we explore the journey of how advanced flood simulation is helping engineers prepare for growing climate challenges, as experts believe smarter planning and better data can strengthen the resilience of cities and communities. As cities continue to expand and climate patterns become more unpredictable, managing floods has become one of the biggest challenges facing modern infrastructure. Engineers today must understand not only how water flows through rivers and drainage systems, but also how flooding affects roads, neighborhoods, public transport, and emergency services. A failure in one part of the system can quickly create problems across an entire region. To tackle these growing challenges, researchers are developing advanced flood simulation techniques that combine hydrological modeling, hydraulic analysis, geospatial data, and infrastructure planning. These multi-scale models allow engineers to study flood behavior across both small local areas and large watersheds, helping them make more informed decisions instead of relying on static calculations. Experts say modern flood engineering is no longer just about predicting where water will go. It is about understanding how water interacts with infrastructure, communities, and the environment, and then using that information to create practical solutions that improve long-term resilience. Many engineers working in this field begin with smaller stormwater management projects before moving on to large-scale floodplain analysis, watershed modeling, and infrastructure planning. Their work often includes studying drainage systems, identifying flood-prone areas, assessing erosion risks, and supporting projects that improve the safety and efficiency of public infrastructure. A key focus of this approach is multi-scale modeling, which connects local problems, such as road flooding or drainage failures, with broader watershed behavior. This helps engineers understand how small issues can contribute to larger flood events and allows them to develop solutions that are both practical and sustainable. Beyond technical modeling, engineers must also balance regulatory requirements, existing infrastructure, environmental conditions, and project timelines. Another important part of their work involves translating complex simulation data into clear recommendations that governments, planners, and communities can use for decision-making. Experts believe one of the biggest challenges is combining information from multiple sources while ensuring that sophisticated modeling leads to real-world action. Whether the goal is improving drainage, reducing erosion, protecting homes, or identifying flood hotspots, the true value of simulation lies in turning data into effective solutions. This reflects a broader shift toward resilience-focused engineering, where the emphasis is not only on solving today's problems, but also on preparing infrastructure for future climate risks and uncertainty. As weather events become more extreme, engineers increasingly rely on advanced modeling tools to help build safer, stronger, and more resilient communities. Thank you for tuning into this podcast. If you enjoyed this episode, make sure to like, share, and subscribe for more captivating tales from India and beyond.